Hey everybody, it's Mr. Carr again. Today we're going to be looking at 5.2 day 3, focusing on reflections as our third transformation. Okay, so first of all, a reflection is a type of transformation where all points are mirrored from a line. That line is called the line of reflection. So what we mean by that is if I look at something like this, here's a horizontal reflection. Every point is the same distance on both sides of my line of reflection. Okay. So that's what creates our mirror image. I can do it horizontally where I flip across this vertical line, or I could do it horizontally, a vertical reflection that goes across this line and moves across the horizontal line. Sorry. Okay. So we look at this. Is a reflection isometry? Yes. It maintains the same size and shape when we go through this. Okay. Now, before we get into these other ones, let's talk real quick about graphing stuff like y equals 2 and x equals -1. Remember, y equals 2 is going to be a horizontal line at a positive 2 in the x direction. So if I go up to like 0, 2, then I draw a horizontal line. X equals -1 means we're going to go 1 to the left, and then it becomes a vertical line. That's going to be important as we go through our other reflections in a bit. Okay. So first we want to do is we want to reflect over the x-axis and over the y-axis. So when I do my reflection of this right here, our pre-image, remember that's where we start at. Let me just fill those out real quick. So point 1 is at -5, 7. Then we're at -5, 2, and then -3, 2. So if I reflect over the x-axis, I'm referring to this right here. Every point that's from the pre-image is the same distance as it is to the image. Sorry. Every point that's from the pre-image to the line of reflection is the same from the line of reflection to the image. So here's what I mean by that. If I go from focus on 3 here, I'm 2 spaces away. So that means that 3 prime is also going to be 2 spaces down like that. There's 3 prime. If I do point 2, that goes 1, 2 spaces away. So I'm going to go 2 spaces again. There's 2 prime. And then when I do 1, I've got 1, 2, 3, 4, 5, 6, 7 spaces away. And that means it's going to go into 1, 2, 3, 4, 5, 6, 7 spaces away here. So here is my image. That's to me the easiest way to do our reflection. We're just going to go what distance away we are from the line of reflection, just kind of repeat that distance the rest of the way. So I fill those out. I've got -5, -7, -5, -2, -3, -2. Kind of see what happens here. Also, if I reflect over the x-axis, all of my y values just are opposite now. I don't like to focus on that because as we change our line of reflection, it's a little bit harder to keep track of that. So I'm just going to stick with just do that motion. Like if we're going to go 2 spots here, go another 2 spots. Okay. 2 spots here and another 2 spots. For the next one, we want to reflect over the y-axis. So I'm going to do that in red. Here's my y-axis. Okay. Same thing as before, when I do my reflection, well, let me write out my pre-image first, I guess. So I've got point 1 is at 3, -1, 3, -3, 3, -5, 5, -2, and then 5, -5. Okay, so those are my 1, 2, 3, 4, 5 points. So now when I reflect it over here, again, if we're going to look at the distance, I got 1, 2, 3 spaces away. So I got to go 1, 2, 3 spaces again. Okay, point 4 goes 1, 2, 3, 4, 5 spaces away. So we can go 1, 2, 3, 4, 5 spaces away. That's where we're getting our primes from. Okay, so 1, 2, 3, 1, 2, 3. Here's 1 prime. 1, 2, 3, 1, 2, 3, 2 prime. And then 3 prime will end up being here. So 5 goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's 5 prime. And then finally 4 prime. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here is my mirror image. Okay, as points go, we have -3, -1, -3, -3, -3, -5, -5, -2, and -5, -5. Again, notice it's a little bit of a shortcut, but only if you're doing the y-axis. You cross over that, all the x values are just changing their signs while the y stays the same. Okay. Let's change our line of reflection now. So instead of doing it as simply the x-axis or y-axis, we can also graph other lines of reflections like x equals 3 or y equals -2. So when I do that, x equals 3 goes 1, 2, 3 to the right, and then this is a vertical line. -2 goes 1, 2 down, and it's a vertical line. I'm still going to do the same exact definition. Okay. So, well, real quick, let me go ahead and fill in my pre-image coordinates in my both of those shapes. So I'm going to have 5, 6, 5, 4, 5, 2, 6, 4, and 7, 6. For the rest of it's -5, 3, -5, 1, -5, -1, and -3, -3, +2. So once I put my lines of reflection in there, again, the distance from the pre-image to the line of reflection is the same as the line of reflection to the image. We're just going to do those same distances. The only difference now is instead of going to the axis, I'm going to go to the line. So for point 1, I go 2 spots. I go 2 more spots for 1 prime. Okay, for 2 here, it's going to be the same thing. 2 spots away from the line of reflection. And then same thing with 3 prime. Goes right there. 5 goes 1, 2, 3, 4 spots. So 1, 2, 3, 4 spots away there. And then finally, 4 prime is right here. Okay. And then now I have my image points, which is 1, 6, 1, 4, 1, 2, 0, 4, and -1, 6. Okay. For the other one, y equals -2, we're going to reflect over that horizontal line. So I'm going to look at 3, 1 space away. So 3 prime is going to be 1 space away. 2 is going to go 1, 2, 3. So then 1, 2, 3 right here. Here's my 2 prime. And then 1 is going to go in another 2 spots. So there's 1 prime. And 4 goes 1, 2, 3, 4, 1, 2, 3, and 4. Here's 4 prime. And then those images are -5, -7, -5, -5, -5, 3, and -3, -6. So the reason I didn't want to look for any patterns in this case is because it's a little harder to see here. We didn't just simply change we didn't just change the signs. We had to do something extra here. So that's why I try to focus on just doing that motion. Do the transformation where you're moving it, like how many places away is a point from the line of reflection, and then just repeat that when you go through. All right. And last kind of a problem here. So when we look at this one, we want to be able to identify our line of reflection. So in this case, and the easiest way to look at it is where is the exact middle between my before and after points. So you can see how point A and point D, it is 1 space here, 1 space here. Point C is 2 spaces, point F is 2 spaces. Point B is 1, 2, 3, 4, 1, 2, 3, 4. So what that means is that is my line of reflection. It's the x-axis. Now, as a reminder, we can also label this as y equals 0. Y equals 0 also is referring to the y-axis, or the x-axis, I should say. Sorry. If I want to refer to the y-axis, that's x equals 0. So that's something to be aware of. X equals 0 is the y-axis. Y equals 0 is the x-axis. So if this is a reflection, then we can kind of see that there. That means it's the same size and shape from before as it is after. So AB is this one right here. So after doing the reflection, notice how it matches up to DE. So that means AB is congruent to DE. When I look to EF, EF is this one right here. So after that reflection, that mirror image is going to put it in this position. So that makes it BC. Okay. And that's basically it for today. Just think about some of these questions real here. What direction does x equals any number? What direction does x equals any number equations graph? X equals is a vertical line. Y equals is a horizontal line. Okay. And then anything else in terms of patterns, there might be some things that might be helpful here. But for our purposes, just the big key here, the distance from a image to a line of reflection is the same as the distance from the pre-image to the line of reflection. All right. And that's it for reflections. All right. Yeah, that's it for today. So take care, everybody.